Hi, hello all. I am Soumya. I am working as assistant professor in the Department of Artificial Intelligence in Data Science in SNS College of Technology. Today, we are diving into multivariate analysis, which is all about studying more than two variables at the same time. Imagine real world situations like customer behavior and medical data or marketing campaigns where outcomes are influenced by many factors, not just one or two. Multivariate analysis helps us to make sense of such complex data. Now we will see in detail. First, let's we see what is multivariate analysis. Multivariate analysis is a statistical approach that examines multiple variables together to find the relationships and patterns. Instead, just asking does height relate to weight? We ask does height, weight, and diet together relate to fitness levels? It is just widely used in business, marketing, healthcare, and research. For example, a hospital may study age, diet, and exercise patterns together to predict the recovery rates. The key idea is when variables interact, we get a clearer and deeper understanding of data. Then, why do we use it? There are three main reasons we use multivariate analysis. First one is to understand the complex data. Real life is messy, outcomes rarely depend on one factor. And second one is to predict the outcomes. For example, predicting the customer satisfaction using price, quality, and service together. Then third one is to reduce the data size. Sometimes we have too many variables and dimensionality reduction helps to simplify that. Think of it like cooking. The taste of food doesn't depend only on salt, but on a combination of many ingredients. Multivariate analysis tells us which ingredients matter most. Then common techniques. One key technique is multiple regression. It predicts one dependent variable using several independent variables. Example, predicting the sales using price, advertising, and discount. Another is factor analysis, which groups the related variables into one factor. For example, if a survey asks 10 questions about satisfaction, factor analysis can combine them into one overall satisfaction score. This reduces the complexity while keeping meaning intact. Then cluster analysis. This groups these similar data points together. Businesses use this for customer segmentation, like identifying the groups of high spending, medium spending, and low spending customers. Then principal component analysis. This reduces the dimensions by combining the variables. For example, in facial recognition, instead of analyzing the every pixel, principal component analysis reduces the data into key features, making the analysis faster and easier. Then visual displays. Multivariate data can be hard to grasp without visuals. That's why we use scatter plot matrix to see the pairwise relationship among many variables. Then second one is 3D scatter plots. When we want to study three variables at once. Then third one is bubble charts. Size of the bubble represents an extra variable. For example, sales by region where bubble size shows the market share. Then last one is heat maps to quickly check the correlations between the multiple variables. These visuals turn the complex relationship into simple interpretable stories. Then best practices. When working with multivariate data, follow these best practices. First one is clean your data. Missing values and outliers can distort the results. Then second one is check for multicollinearity. If two variables are almost identical, like a height in centimeter and inches, avoid using both in regression. Then third one is choose the right method. Regression for prediction, clustering for grouping, and PCA for dimensionality reduction. Then fourth one is use visuals. Always accompany analysis with scatter plots, heat maps, or bubble charts to make the interpretation easy. In short, good data good data in and good insights out. Before we end, let's recap. Definition: multivariate analysis studies the three or more variables together, and techniques like regression factor analysis, cluster analysis, and principal component analysis. Then visuals we use here is scatter plot matrix, bubble chart, and heat map. Best practices is clean the data and avoid the redundant variables and use the visuals. So the next time you see a problem with many influencing factors, remember multivariate analysis is your go-to that method. Thank you for listening. Multivariate analysis may sound complex, but in reality, it's a smarter way of analyzing the data when multiple factors play a role. With the right techniques and visuals, we can simplify the complex patterns and make the meaningful predictions. Thank you.